What is a matrix? Well, basically a matrix is a collection of numbers, and we're going to organize them and generally put them inside some kind of bracket. And oftentimes we name them with a capital letter. So capital letter as a variable, you'll normally think this is a matrix, B or C here. So here's a generic matrix. It's an m by n, so m rows by n columns. And the rows go down this way and the columns go this way. So a generic element A11 is in the first row, first column. A21 is in the second row, also in the first column. And so we can name off any element of this matrix. A32 would be third row, second column. So this has dot, dot, dot because we don't know what size this matrix is. So that's the most generic type of matrix we could have. So here are two specific matrices. Plural matrix is matrices. Capital B, this is a 2 by 2 matrix, 2 rows and 2 columns. And B21 would be the second row, first column, so it would be the element 0. And capital C here is another matrix that has dimensions 3 by 2 for 3 rows and 2 columns. So this is how we can tell the shape of a matrix by its dimensions. And this is what they look like, just collections of numbers. Why we're so interested in these will become apparent in subsequent recordings. This one we're just going to set up the basics. So two properties we're going to learn about matrices in this video are scalar multiplication and matrix addition and subtraction. A scalar is a constant. So this means multiplying a constant times a matrix. So for example, I might want to multiply 4 times the matrix B. So that's the same as 4 times, then I wrote the matrix B out with its terms here. And scalar multiplication proceeds exactly like you would expect. You multiply each of the terms in the matrix by the number 4. So 4 times 1 is 4, 4 times 5 is 20, 4 times 0 is 0, 4 times 3 is 12. And that is scalar multiplication. It's actually that simple. Matrix addition and subtraction are pretty straightforward as well. Matrix addition, you add the corresponding element in the same position of each matrix. So you go 1 plus 4 is 5. 5 plus 7 is 12. 0 plus negative 2 would be negative 2. And 3 plus 3.5 would be 6.5. So this was our friend matrix B from above. This is some other matrix. Maybe I'd name it D at this point. So B plus D, if in that case, would equal a new matrix here. Maybe I'd call it E that has these numbers in these positions. Now something that's interesting is these two are the same shape, so we knew which numbers to add together. If I were to try to add matrix B to matrix C, I really couldn't do it. I wouldn't know exactly where to put them. Should the 1 be added to the 4, or should I slide it down and add the 1 to the 7 because it would fit down here on these 4? So you simply cannot do matrix addition unless the matrices have precisely the same dimensions. So this would not work for matrix addition. This one worked because they're both 2 by 2, 2 by 2. We can add them together, we get a 2 by 2. Matrix subtraction is the exact same thing, only you would put a negative here and you would subtract 1 minus 4, 5 minus 7, and so on to get your answer.